Okay, the action tonight is going to be quick and sharp because by 8:15, after your penetrating questions to our guests, Brian is going to be signing copies of his book, I presume, in the lobby here. So we're going to end then, and that doesn't give us a whole lot of time.
I have a few copies too. I brought a few copies with
Of
me.
his book?
No, of my book.
Come on, Alex. All right. I just have about 45 minutes worth of prepared notes here to talk to you a little bit about the Nobel Prize, because Alfred Nobel, he was sort of in a dynamite business, actually. Don't worry, it gets worse. Well, he had hundreds of patents, right? Dynamite happened to be his best-known patent and probably the most lucrative. But at one point, he read an obituary for himself. This was a little premature and somewhat reminiscent of the obituary that Mark Twain read of himself, and which he responded to by saying, well, tales of my death are somewhat exaggerated. Now, Nobel did not say that, but he read this thing, and the obituary was actually rather critical of him, saying that he had made all his money in the armaments business. So he decided to, in fact, atone for that by establishing these prizes in physics, medicine, literature, chemistry, physiology, and of course the Nobel Peace Prize. He did that. This is rather reminiscent, since you're all from the Bay Area here, I presume, of Sarah Winchester, right, who built this endless house down in San Jose to atone for all the people that had been killed by Winchester rifles. So that's what Alfred Nobel, that was the motivation for Alfred Nobel. It was an obituary. Okay. Tonight, two researchers, both astrophysicists, who could have had a nifty doodad to show off during dinners at their homes, had things been slightly different, and what they think of the Nobel Prize anyway. Each will speak now for 5 minutes, literally 5 minutes, that's what they get, and then we'll have a bit of discussion, and eventually you will have the chance to grill them like steaks on the Barbie. So that's the way it's going to happen, and we're going to begin with you, Brian. Brian is... Well, I have the wrong guy here, Brian, but it's okay. Is it okay if I use some other intro for you?
I'd like to be like Alex.
Yeah, you want to be like Alex. Brian. Brian is a distinguished professor of physics at the University of California, San Diego, and he is author of Losing the Nobel Prize. Brian, you have 5 minutes. Lay it on him.
All right. Well, it's fitting, and it's very nice to be here on this evening tonight. And I thank everybody for coming out, for Frank and Rebecca and Bill and Seth, of course. For organizing this. Thank you, and especially to Alex, who's been a remote mentor to me for many years. I've followed your career, and I try to emulate you as best as I can, one of the top professors in the world. The Nobel Prize has played an interesting role in my life, actually, and the slide that was just shown, that was the image, the icon for tonight's presentation, is really indicative of some of the burdens that I feel that scientists and even non-scientists are feeling nowadays to aspire to win what has become pretty much the most hotly contested idol that you could potentially win. And it's become so important to scientists and to economists that you see the repercussions of it throughout many different fields. And I came to worry about what it's doing to my field after having an encounter with it, as I describe in my book, where I came very close to grasping it. And then immediately thereafter was blown away by the most microscopic particle in the universe, a particle of dust, and really in vast assemblies of dust. So tonight, I'm pleased to present the villain of my book, which is a dust grain in the form of what's called a meteorite, that you will get with each book if you pick up a book while you're outside. And I have provided a meteorite, as I say, the villain of this book, but it's also sort of the hero, because in this image I'm showing up here, this is our polar bear telescope, in the high Atacama Desert of northern Chile. You see in the background this Milky Way galaxy. And the Milky Way galaxy may be, hopefully for folks here at SETI, teeming with life and technosignatures and biosignatures. And the question of whether or not that life would exist without dust is a really fascinating one. Carl Sagan, one of the progenitors of all the great things that bear his name, the Cosmos series, and of course a lot of deep work with SETI, and of course the book Contact, the great Carl Sagan said that the Earth is nothing but a mote of dust, really suspended poetically on a sunbeam cast from this local star. And really, dust flows through our veins as well, which I found very interesting, related to the work that Alex does through these most violent processes in the local universe called supernovae. And the connection from the smallest things in the universe to the entirety of the universe really impelled me to write this memoir of what it's like to be a scientist and aspire to want to win the combination. There's no greater honor in all of humanity, I claim. There's no Oscar award. There's many different types of Oscars and Academy Award type things and Emmys and so forth. There's many different types of Olympic or sports or World Series titles that the Giants won't win again, hopefully. No, just kidding. I love the Giants. but there's nothing really equal to the Nobel Prize. Sadly, in fact, just last week, a very prominent economist committed suicide. And according to the suicide note that he left, his failure to win the Nobel Prize last year for work that he had done in climate change decades earlier, which went to 2 other people, and that's maybe part of the problem, was a contributing factor according to sources quoted in the New York Times. And I felt like that's such a shame. After going through this process myself, coming close, thinking we witnessed the birth of the universe, the birth pangs that created the Big Bang, and to come up short all because of this microscopic grain of dust, really made me feel like the process of aspiring to the Nobel Prize is a futility, is a futility, which, if you know your Proverbs, is also where we get ashes to ashes, dust to dust. And it's really quite unfortunate that the Nobel Prize casts such a big shadow on science and even non-scientists. And hopefully we can use the prestige of the Nobel Prize to reform it. And that's what I attempt to do in this book.
Terrific. Well, Brian, thank you very much. Next will be Alex, his 5 minutes of fame. But actually, he's a professor of astronomy at UC Berkeley. You may have heard of Berkeley. It's on the other side of the bay. And he has been repeatedly voted the best teacher in the inner solar system. So, Alex, you're up.
Okay, thanks very much, Seth, and thank you all for being here and the organizers for doing this whole thing. So my perspective is a little bit different from that of Brian, although I actually agree with a number of the things he says in his book. I was involved in the study of the expansion history of the universe, in trying to predict whether it'll keep on expanding forever, albeit progressively more slowly, or whether it would someday come back in a big crunch. And we studied very distant exploding stars, supernovae, in order to determine the distances to which we were looking, and hence the amount of time back to which we were looking. And by looking at the light, we could also tell how much the universe had stretched. So by looking at, in a sense, the amount of stretching as a function of time going back, you can recreate the expansion history of the universe, see how much it's been slowing down, and then figure out whether it'll stop someday and reverse its motion or continue expanding forever, though always slowing down. And what we found was that the universe is actually speeding up in its expansion. It has been speeding up for the past 4 or 5 billion years. This was completely unanticipated. It leads to the idea that there's dark energy in the universe pushing it apart. And we're now trying to understand what that dark energy is. But I had the unique perspective of being the only person who was, at one time or another, a member of both of the teams that nearly simultaneously made this discovery. I started with one team, I then switched to another, in part because of cultural differences in how to do the science. But, I was privy to a lot of what was going on both teams, so I have sort of an insider's view of that. The discovery was made in 1998, or announced in 1998. It was verified in the subsequent 13 years or so until 2011, when the Nobel Prize in Physics was, in fact, given for this discovery. But according to the rules of the Nobel, which I think we'll get into, or at least according to the conventions, only the team leaders typically get the Nobel Prize. And though I was the one person to have been on both teams, I was not, technically speaking, a winner of the Nobel Prize. Nevertheless, the team leaders understood that without the rest of us working in the trenches, the discovery would never have been made, they would never have been honored with the Nobel Prize, and so this whole thing wouldn't have happened. And so they spent a good fraction of their prize money flying the rest of us out, and we participated in all the parties and all that. The only thing I didn't get was a gold medal, a handshake from the King of Sweden, and a fraction of the $1.5 million, okay? But otherwise, I did get the Nobel Prize in the sense that that research was rewarded with Nobel Prize for the discovery of the accelerating expansion of the universe. It's just that I, technically speaking, did not get part of the Nobel Prize. And so it's a different perspective than doing an experiment which led to a result that was interpreted in a different way than you had thought. And in so doing, it wasn't as exciting as what you had hoped for, and the reality was this dust rather than ripples from the early expansion of the universe. So I don't consider myself as having lost the Nobel Prize.
Well, does that help you sleep at night?
Well, I mean, I've come, I accept it. It's fine. I don't necessarily agree with all the rules, and these are the things we're going to talk about. But those are the rules or the conventions. And at the banquet, I positioned myself between two of the physicists who were part of the Swedish Academy of Sciences that makes these decisions. And by carefully pouring more wine into their glasses, making sure it was full the entire evening, I was then able to eventually ask some rather penetrating questions in, I believe, a diplomatic and a polite way. And they essentially admitted certain things that we can talk about later on. For example, it's not in Nobel's will that it can only go to a maximum of 3 people. They wait until someone dies if there are 4 people or more, or they don't give the prize at all. I mean, I got these people to essentially admit these things, although I probably shouldn't say this because this is being recorded.
Well, all right.
So I've come to terms with it. Yeah, it's okay.
All right. Well, I want to. One thing I want to ask both of you. Actually,
Yeah.
it seems to be a story that's widely believed that Nobel had specified no prize in astronomy because he had been cuckolded by an astronomer.
No, that was a mathematician.
No,
and
not
it's an
even
apocryphal tale.
All right. We won't talk more about that. All right. Now I want to get back to you, Brian, because you were trying to do an experiment. I mean, I think you're all well aware. These are both cosmology stories, right? They're talking about the big things in the universe. They're not talking about the rotation of late-type stars. None of this small-scale stuff. This is big stuff, where the universe came from, how it began, that kind of stuff. Brian, what were you trying to do? Obviously, you were doing something that you got, tripped up by dust, but explain what it was you were trying to get at.
Well, I would say it's very hard to do what Alex and I do, and you do as well, which is to be an astronomer. We don't have the ability to do experiments that our biology friends do, or our chemist friends do. As I always say, I don't know what they do in the biology building, but I know it involves frogs or fruit flies or monkeys or whatever, and they get to do an experiment. They take the object that they're studying, they make some change to it, they observe what happens to the object under study. So they put the frog in the boiling water. No, they don't do that. Especially, maybe at Berkeley they do that, but not at San Diego.
Wait a minute. Maybe at San Diego they do.
The ocean's pretty warm these days. So they can do an experiment. We can't. We can't actually change the temperature of a late-type star or change the expansion rate of the universe and see what happens to the rest of the fallout from doing such a change. But I always say we have a benefit that no other scientist has, which is we have a time machine, which is a telescope. And if I peer out in my spyglass, wake up over there, please wake up. No, if I look back, I'm seeing you at some time in the past when you were younger. This usually makes people move to the back of the room because light travels about 1 foot per nanosecond. So every row behind me, I'm seeing you effectively 1 nanosecond younger than someone in the equivalent age sitting in front of you, which means that you can look back to the beginning of time if nothing gets in your way. No head in front of you, no wall of this room, no city lights, and no planet behind us. You could see through to the beginning of time if you could see this ancient light called the cosmic microwave background radiation, which is this kind of, I call it the cosmic wallpaper that surrounds us in all directions. It was discovered by Penzias and Wilson in 1965, resulted in the first Nobel Prize in cosmology ever awarded in 1978. And the question of how did the universe come to get its spots, these perturbations that we call the anisotropy of this cosmic background radiation, really led to us being here tonight, because it reflects how gravity, energy, dark matter, etc., how they behave over cosmic time and gravitational collapse to become us. I was curious in 2001 if you could build a telescope just like this, but sensitive to this wavelength of light, microwaves, not visible light. And if you could do such a thing, you could peer back to the potential beginning of time, looking for waves of gravity, gravitational waves, gravitational radiation. And we set out, we built an experiment called BICEP that was placed at the very bottom of the world, Antarctica. And when I created this experiment with my colleagues at Caltech, we were told in no uncertain terms by Nobel laureates themselves that this, if we were successful, would win certain Nobel gold. And I'm a little ashamed to admit that drove me. It impelled me in my career as an early scientist because I kept getting this message that just as if you're the greatest actor or actress, if you win an Oscar, you win a gold medal, you're at the Olympics, you're the best athlete, I felt I had to win a Nobel Prize. And it was reinforced throughout my career. And it was mostly the joy of scientific discovery that impelled me. But I have to be honest, part of it was that Nobel gold.
Okay, so you admit to a certain degree of ambition.
Correct.
Yes. So you were inspired by the Nobel Prize to, in fact, pursue this idea. But maybe you could explain to the audience very briefly. You were looking for something in this cosmic background radiation, right, that covers the sky, that would tell you what about the early moments of the universe?
So when you look back at this image, is sort of a deity's eye view of what the universe would look like from afar. So it shows our galaxy as this orange band of microwave energy around here. But away from the galaxy, you see these fluctuations, these perturbations in the amount of energy and matter in the early universe. This is a snapshot made by the WMAP science team, a satellite about 15 years ago. Made this image, and then they printed on a beach ball. And sort of like, you have to envision yourself being at the center and looking out. But we'll consider ourselves in the Bay Area to be godlike creatures. So we're looking at our universe. But how did these things come to get here? One of the most interesting questions that people ask is, how did I get to be here? I usually ask people, what's your most, favorite day of the year? Alex, what's your favorite day of the year on the calendar? Don't say.
July 4th.
July 4th.
Because of the explosions.
Explosions. It's also the beginning of our country.
Right.
A lot of people say their birthday. What's their birthday? It's the beginning of you. People want to know what happened when they came about. But with the universe, we don't start in the middle of the story. You had parents, I had parents, great-great. But with the universe, we may be looking at something that had no preceding event. And I set out to detect a signal, which would be, in a technical sense, would provide concrete evidence for the smoke from the smoking gun that ignited the explosive Big Bang that we observe today.
All right. Now, Alex, Brian's interested in the beginnings of the universe.
Yeah.
You presumably were interested in its future.
That's right, in its fate.
In its fate. All right. Well,
Yeah.
you can put a penny in it, down a fisherman's wharf into a machine. But the deal is that everyone expected that either, as you've already pointed out, either the universe was going to sort of slow down, reverse direction, and we'd watch everything getting closer every night. It would be
Right.
great for astronomers of the future, and all that. Or it would just sort of asymptotically come to zero. When did you realize that neither of these expectations were the right thing?
Well, it was the end of 97, beginning of 1998, when my postdoctoral scholar, Adam Rees, who was a Miller Fellow in the Miller Institute for Basic Research in Science at Berkeley, and who was tasked with measuring and analyzing the data for one of the teams, Brian Schmidt's team, he brought his results to me because I was his faculty mentor at Berkeley. And my jaw just dropped. I thought, how could you have measured these distant stars to be as faint as you claim them to be? That means they're farther away than they could possibly be, and that means that the universe, must have accelerated. And it just seemed to me that he hadn't made the measurements properly. So I said, go back and make the measurements again. But he did, and other people on our team did. So it was just an amazing moment. But though we were driven by a desire to measure the past history of the universe and thus predict its fate, we were, I would say at that time, not at all driven by Nobel dreams, because at best we would have found one of the two expected solutions, the ones you just articulated, and our data would have not been so definitive, and there were other pieces of evidence that the universe has something like 30% of the amount of matter that you need to bring it to a halt, and so people expected that it won't be brought to a halt, it'll just sort of slow down forever. So we were expecting to confirm one of the expectations. And I would say that the Nobel Prize is sufficiently rare. So few physicists will get it in physics, let's say, or chemistry and chemists, that you usually can't be working on a project that's so obviously a candidate for the Nobel Prize if you succeed. So I would say, your situation, though I don't doubt it at all, and I agree that I would have told you that if you manage to do this, you'll get a Nobel Prize. Yeah, but there are very few questions of that sort. And so most physicists and astrophysicists in their daily work are driven almost entirely by this passion to understand the universe, and sure, you want some of the glory and the funding that goes with it, et cetera, and so you want recognition and you have those sorts of aspirations, but they don't quite reach the Nobel Prize. Indeed, people who say, well, they're going to win the Nobel Prize, you usually say, yeah, right, I mean, they're usually, so in a sense, fakes, but not always, not you, okay? And not, Carlo Rubbia, who was looking for one of the quarks or whatever, right? There are sometimes questions that are such obvious candidates for the Nobel Prize that you could be driven by that. But I would say most scientists are not reasonably and realistically driven by a desire to win the Nobel Prize because they know that there's essentially zero chance.
So you were not inspired to do this experiment by the thought of a Nobel Prize.
No,
this was going to be
not at all.
an interesting publication to find a number that nobody had.
Yeah.
Okay. Fair enough. By the way, I would like to ask, since this is about the Nobel Prize, but the Nobel Prize these days is not the only prize in physics, and it's also not the most lucrative prize in physics, but is it still the most prestigious?
I think clearly it is. I mean, most people, if they know somebody, has won a Nobel Prize, it assures things. Alex knows this better, than most. It's the only way that you can get a guaranteed parking spot in front of his building at UC Berkeley.
Anywhere on campus.
Yeah, anywhere. NL, Nobel laureate. I was told, as a young professor starting out, that this was, I was chosen because they thought I would have a good shot at winning a Nobel Prize by someone whose father had won the Nobel Prize. So there is a culture. It's a subtle thing. I agree with you. I actually think the types of discoveries that Alex's team made, and I argue this is actually the most controversial thing in my book, which I didn't expect it to be. But I propose, just as you have, blind tests for certain things, there are certain effects in the medical industry or in the legal system, that you should really only give a lot of credit to these types of serendipitous findings. He said that he set out to measure something completely different from what they measured. And so at first you were like, that's really weird, and you start to doubt, maybe you made a mistake. You recounted it rather endearingly. And I think that's the way that we should reward experiments, because when you set out to measure something so big, and because of what you've discovered with dark energy, now it has nucleated a field of research that will certainly result in another Nobel Prize for someone who identifies what the dark energy is, or some counterpart for it. Same with dark matter. That's when you're looking to find something, oftentimes you find it. And in our case, or I'll say in my case, that's what happened with our particular quest. We knew that it had this potential. We are, of course, animated by the scientific curiosity that all good scientists have. But part of it is you sometimes find what exactly you're looking for, and that's Richard Feynman said, the first principle is you can't fool yourself, and the second principle is you're the easiest person to fool. So it's this two
confirmation bias.
Confirmation
really.
bias,
yep. Yeah, I mean, in fact, Adam was enormously careful in what he did, and he was a young postdoc, and he didn't want to screw up, but after doing test after test, and the result was still the same, at some point you've got to be bold and say, okay, we're going to publish this stuff. And there was considerable discussion in our group about whether we should publish such an obviously crazy result. But I thought Adam had done an amazing job, and he had convinced me that he had done it right. And Brian Schmidt had redone the calculations, and so enough people on the team had done it that we thought that, okay, if we've made a mistake, it's not something obvious like 2 + 2 = 5 in a programming error. Then you lose your funding, you lose your reputation. But if it's something like, heaven forbid, dust, then it wouldn't be so shameful because, well, the universe teaches us other things sometimes along the way.
Yeah, I mean, there's a saying attributed to you, actually, that an observer only has to be wrong once in her life or his life to lose their career, and a theorist only has to be right once in their life to have a career.
Yeah, I didn't come up with that saying, but it's often attributed to me, right?
But, well, don't fight it.
Yeah, why would you? Don't ruin your brand.
Right.
Yeah. Well, okay. I think it was Isaac Asimov, actually, to follow up on what Alex was just saying, who said that, it's not that when scientists discover something, they say eureka. What they say is, that's funny. Right. So that happened to both of you. But maybe you would like to say something, Brian, about, you've mentioned dust, and I don't want you to give away the storyline of your book here, but maybe you want to say in a few sentences how dust tripped you up. You were at the bottom of the pole, the bottom of the globe there in the South Pole. You chose that not because of the cuisine, by the way. You might.
No, actually, yeah, there are penguins there. If you don't
There are no
decide
penguins.
between, no, if you can't decide between chicken or fish, you go. No, I'm just kidding. There are no penguins there. Please. Actually, there are at the gift shop. You can get a stuffed penguin. So why did we choose there? We chose there because it's the driest continent on Earth. It's very high. It's about 9,000 feet above sea level. And what we're looking for are microwaves from the Big Bang that have been traveling for 13.8 billion years across the universe to enter in our telescope. We don't want them to get absorbed in a water molecule floating above the San Diego County telescope, or if we put it in San Diego. So unfortunately, we have to go down to the South Pole to do it. And now I go to the high Atacama Desert. You go places that are dry, because microwaves are absorbed by water. That's how your microwave oven works. And in our case, what we were looking for was a region very far away from this bright glowing region of our galaxy. So we had pointed our telescope basically in this region of the sky, far enough away that we could hopefully safely ignore the contaminating effects of dust and of what's called synchrotron radiation. And dust is populated in all galaxies. Actually, one of the things I think Adam, I quote in the book, what he had to do is look in other galaxies and see how much dust they have and make a survey of how much dust there is in these types of galaxies that host these type 1a supernovae. We had been really lulled into a sense of security by analyzing data from previous experiments, none of which had been really as sensitive as we needed, because ours was the most sensitive experiment ever done, still holds the record for the greatest sensitivity. So we didn't make a blunder. Instead, what we saw was this twisting, curling pattern of microwaves called B-mode polarization. And the twisting pattern of this polarization was thought to be unequivocal evidence for the inflationary origin of the universe. And this couldn't be bigger stakes for cosmology, because most theorists believe that if inflation occurred, there's something called the multiverse, which means just as there's not just one planet, one star, one galaxy, there's potentially an infinite number of universes in the multiverse. So if we discovered these twisting patterns of microwaves, then we would know that inflation took place. If we knew inflation took place, we'd have good evidence for the multiverse. So again, the stakes couldn't be higher. Unfortunately, there's more than one thing that can make these twisting, curling patterns of microwave polarization, in particular, dust grains of little magnetized dust, can get aligned in the Milky Way's magnetic field and make exactly the same kind of pattern. And lo and behold, when you're trying to find something, sometimes you find it. There was only one way that we could unravel for good what the source of that microwave twisting polarization was, and it was held by our arch rivals on the Planck experiment, which is a €1 billion science project launched by the European Space Agency. They were not willing to share the data with us, and it turned out they didn't have the sensitivity to see what we thought we had seen. And so we were kind of in this battle against ourselves. In part, again, I can only speak for myself. I have emails to prove it, but I'm only speaking for myself that the Nobel Prize played a role in this decision. And actually, the way that you titled your paper actually came into, like, how are we going to couch this discovery so that someone can't come along after us and say, you were too tentative. You weren't bold like Alex and Adam and others and Brian and Solworld. Instead, you hedged your bets. You weren't good scientists. Now we are. So we were worried about that. So everything was crafted in a way to show that we had made this discovery of a lifetime. Now, we didn't make a blunder. I always say, we didn't leave the lens cap on the telescope, but our interpretation had to be retracted, essentially recanted, about 8 months later. So it all came to a head very quickly.
You're not the first
to
one.
add one little thing to that, the dust could have tripped us up as well in our studies, because when there's dust in the way, a supernova will look fainter than if there isn't dust in the way. And so if you don't include the dust, but it's there, but you don't include it in your analysis, you will think that the supernova is farther away than it really is. It's like looking at a headlight through fog, right? This is how some accidents occur. You think the car is farther away than it really is, and you misjudge its distance. So we had to correct for the dimming effect of dust, and we did that by looking at the colors of the exploding stars. Notice when the sun is setting, not only does it look dimmer, but it looks what? More red, right, especially when there's a lot of particulate matter, like when we had all the fires a year or so ago. So we looked at the colors of the stars that were exploding, and from the colors we could tell that there wasn't conventional dust in the way, and then there were other arguments we used that it couldn't have been other unconventional kinds of dust. But honestly, we were even at the time of publication still somewhat worried that it might be what's called gray dust. In other words, dust that doesn't cause this reddening effect of starlight. But we had some arguments against that as well. So yeah, dust is a tricky thing, and Brian's team did an amazing job, but they got tripped up by a very, very subtle effect.
He's in good company. I mean, this falls into the category of unnecessary example. But in 1900, you would have said we were in the middle of the Milky Way galaxy, and that was because J.C. Kapteyn, who was trying to figure out where are we in our own galaxy, was tripped up by the dust, and everything looked far away. It was like looking at you're in a city in a fog, and you think you're in the center of the city because there are many houses this way is that way, so you figure you're in the center, and it's just the fog.
Yep.
Okay, I want to get to the question of the Nobel Prize because we're going to go to Q&A here in about another 8 minutes. So what about it, Brian? I mean, you've already admitted that, you were spurred to do this and maybe to, if you will, jump to conclusions. Jumping to conclusions may not be fair, but that you published a very strong paper, or were planning to do so, because of the Nobel Prize. So how do you evaluate the influence of the Nobel Prize on science in general?
I think it has a mixed record. I come in my book has a double entendre meaning, which is, my personal story of aspiring to win it and having it slip through my fingers and lose it personally, but also that there are aspects of it that need to be lost, gotten rid of, in other words. And these are the aspects that distort the way that science is portrayed and the way that science is taught. A lot of times if you go to a talk or you read a book, almost on any book you pick up, you'll find out who won a Nobel Prize for something. You'll find out that this, led to a Nobel Prize, as if that's the solidification, and I always point out, well, Newton didn't win many Nobel Prizes, but he was still a great scientist, and the influence therein is quite astronomical and titanic.
Didn't live long enough.
Yeah. Well, he lived pretty ripe old age, but then you ask, well, what could the Nobel Prize be used to do if it were in the form that Alfred Nobel originally intended, and we hinted at this earlier, it was never intended to go really for the types of discoveries that it goes to today. In fact, Alfred only had 3 criteria, and they were, it has to go to a single person, a man, basically, who made the greatest beneficial discovery to mankind in the preceding year. So Alex already said 13 years elapsed between discovery and award, and you can argue if that's a good thing or necessary or not. It went to 3 people, not 1, and on a daily basis, if dark energy really matters that much to you, you should consult an astrophysicist, or a therapist. I'm not sure which one, but really, it's not. The first Nobel Prize went for the discovery of the X-ray by Röntgen, and that had immediately beneficial purposes for medical diagnostics, saved millions of pain hours and lifetime accrued over a lifetime. And it was awarded the first year it was eligible to be awarded. So I think, I approached this book, which only has 3 chapters out of 13 about the Nobel Prize, but what would an executor say? So Alfred Nobel never married, so he was never that bad word that Seth said earlier. He never had kids that we know about. He had nieces, and he had 1 niece, and he had a couple of nephews, and he gave some money to them, but most of his earthly reward went to endow this Nobel Prize. And I think I treated myself as like a lawyer, an executor of an estate. What would Alfred Nobel do if he knew what became of his will? Because I have news for you. You're all alive now, but after you're dead, there's nothing that you can do about how people handle what you wanted for your rewards in the hereafter. So I treated myself like that. What would he say of what's become of his prize? I think he'd say it has mixed record, and I'm attempting in the book to use the prestige of it to burnish its image so that it may never tarnish. So I'm actually not an denier, a Nobel Prize denier, but instead we should not, crucify it. We should resurrect it in the way it was originally intended.
So some woman asked me today, how many women have won the Nobel Prize?
3.
Not
3.
many.
In
Right.
physics.
Yeah.
In physics,
Yeah.
yeah.
Any further commentary on that?
Well, it's pretty shameful.
It is, yeah. And we were talking.
But let me just, to add something to what Brian said, I don't disagree with some of the statements you made, but the prize had to evolve over time because the criterion that it's given for work done in the immediately preceding year, that just can't possibly be done anymore because it takes a long time to verify things. In our case, it took 13 years. That's on the short scale of things, If you were to give it for the immediately most important looking discovery of the preceding year, half the time you'd be wrong. So that part, I claim it's okay that they're waiting a long time.
Maybe that would be a different prize.
And then
right.
secondly, very few people do research truly on their own anymore, and so giving it to one person doesn't seem like the right thing to do anymore. I would argue that it should be given to teams, all right? So there, I would, sort of go to where the Breakthrough Prize in Fundamental Physics, for example, is given for teams, and we got that in 2015, and each of us was recognized. So that part I would say, and then the arbitrary three-person thing, I think, is dumb, and is not in the will. And then the posthumous thing, that,
I ask you, because I have so much respect for your viewpoint. There's no law of physics that says the Nobel Prize has to be the most prestigious award ever given on Earth. There's no law that mandates this esteem that it has. So I ask, why has it become so prestigious? Why does it matter so much more?
Because of the history.
Because of the history.
Because of the history of who's gotten it.
Right. So there's not actually, as you said, the Breakthrough Prize. And I've heard people disparage even the Breakthrough Prize without any offense intended, saying anyone who's won it would trade all the money that they got, which is 3 times as much as for the Nobel Prize, which I think is really an unfortunate thing to say. It holds it up, as I point out in the book. It has all the hallmarks of a religion in that it has a founding father, a patron saint, Alfred Nobel. It has this Vatican-like committee, the Nobel Academy, which are really the people that make the decision. There's some inputs. I was asked to nominate winners of the Nobel Prize the year I could have been eligible to win it, which was kind of like, I'd like to come to the SETI Institute tonight, but can you get me an invitation to a better SETI Institute? It was kind of humiliating to me, but I went through with it, as I describe in the book. But there's no law that really causes, so why has it become like this? And I claim, it has a lot of features of a religion, and people don't like to give up their religions. As anyone who's, if you've been approached by a Jehovah's Witness at your house, you usually don't give up your religion, even if you are, so inclined.
Well, what about the fact that some woman reportedly said, when asked about the possibility that she might win a Nobel Prize, said, well, I don't want to win the Nobel Prize, because if I do, then people will assume that I don't need funding for my work anymore, ever.
Yeah.
It isn't really a lot of money today.
Yeah. When you look at the
look at the price of houses
it's
in
$1.5 million.
Menlo Park.
Well, it's $1.5 million, and if it's given to 3 people, which is pretty common these days, so that's $500,000 apiece. Or typically the way it's done is that half of it goes to one of the people, and then there might be a team of 2 that got it as well. So it's a quarter and a half. But anyway, it's roughly $500,000, and after taxes. Well, it's better than a slap in the face, but a big experimental physics or chemistry or biology lab, it's not going to fund for that long.
Okay.
Yeah, those big labs require millions
and what about
millions of dollars.
the point that you made, Alex, that today a lot of research is conducted by teams. You look at the author list for the Higgs boson discovery.
Yeah.
Right, it goes on.
There's
It's longer than the
6,000
paper
people.
or something. Yes, exactly. But that's in the nature of science, the days in which individuals made the big breakthroughs.
Right.
Most of the time, it's probably behind us.
That's a bygone era, I
Yeah.
would say. And in that sense, I think the evolution of the prize is a good one, but if anything, I would go farther and say it should go to teams, not necessarily individuals. But not just one, and not in the year right after the discovery, because the discovery has a good chance of being wrong.
But then I want to ask you just as an honest, so let's say you have this, even more wealth than you. You're a man of great wealth, as I understand. No, I'm just kidding.
No, I'm
not.
I'm just a professor of astrophysics like you.
A state employee. We're state employees,
Right,
ladies
exactly.
and gentlemen. Don't tell Gavin Newsom we would do our jobs for free, though, right? But if you look at, how the prizes change, imagine you had a wealthy estate and you gave it away to do specifically these things. Now, you could say later on people can interpret how they want, but it's kind of like the debate, should the Constitution be as the Founding Fathers, or should it be a living document? And I think, I could see things either way. So I agree with you. There are ways to reform, but once you go a little way, it's like a quip from George Bernard Shaw that I put in the book. I won't tell it here because there's young people here, but sufficiently about, how to entice and attract a woman based on money and what that would do to her. And he said, well, you just have a high price for what, for going on a date with me, basically. So I think, it's interesting to think about how, once it changes, where do you stop? And has it become a new prize? And what's wrong with that? And I think when you look at it as 450 members of the Swedish Royal Academy of Science that determine the prestige, the power, the ability to really set these trends in science, I think it has some real severe shortcomings.
Yeah, it has some problems. I don't disagree.
This is just to the audience, many of whom are still conscious I would say if you want to ask questions of our astrophysicists here, there's a microphone over there. I guess that's the only one. Line up docilely at the microphone, and you will get the chance. We're gonna go to the questions in about another 5 minutes. Okay, so the first Nobel Prize in Physics was awarded, I think, 1901.
1901, yep.
Okay, I remember that. Now, the question is, is anything changing? I mean, is it all ossified? Is it all sclerotic now? Or do you think that the committee will change the rules? I mean, these points that you make are all good ones. These are not stupid people. They probably are aware of some of this.
I got some feedback from the Royal Academy, from members of the Royal Academy. I had people tell me on the Nobel Committee that they agreed with me. And then I had the Secretary General of the Nobel Swedish Academy write in a public response to an essay I wrote for an article, magazine called The Conversation. And in it, he took issue with basically every point that I had. And so one of them was about Rosalind Franklin, who was one of the few people that actually came up with the data that allowed the double helix structure of DNA to be uncovered. And I put in there, really, there's nothing that prevents you from giving her the Nobel Prize in medicine and physiology next year. I said, show me the law of nature that says you cannot give a Nobel Prize posthumously. Oh, no, that's forbidden. And he said, we're not allowed to do that. What do you want us to do? Go back and give her heirs the money that she would have won? I said, no, I want you to admit that you completely overlooked what you did in the past, just as Hollywood has its Me Too moments. I mean, for the Nobel Committee, they have to reconcile with their history, and not all of it's clean. And in this case, she was disavowed or disallowed the Nobel Prize decades before this clause that prevented posthumous awards from being awarded. So that's not even a legitimate excuse. They didn't give it to her. It was stolen by, stolen in some sense, James Watson and Francis Crick, who, did a lot of incredible work, and Wilkins as well, but that she didn't have this recognition, I think is a great shame and a great blemish on, on the record of the Nobel Academy.
But what's the bottom line? Did they say, we're going to try and do better, or did they just make excuses for what they did?
I think in this case, they refused to retract. So James Watson, you can look him up, the kind of odious things that he's been proposing for many years. Up the road, William Shockley, who had some really awful views about eugenics and racist ideology. They refused to take it away. And I think that's really, really bad. I mean, even the American Academy of Motion Picture Arts and Sciences rescinded Harvey Weinstein's membership in that committee. So I think if Hollywood, Motion Picture Arts and Sciences, if they can do it, surely the Nobel Prize can do better for their own sake.
Basically, they never admit an error.
Correct.
It's as Brian says, and they never change their minds. And there's, the example you gave, but in astrophysics, Jocelyn Bell Burnell discovered pulsars using a radio telescope that her advisor conceived and built, but her advisor got the Nobel Prize, and she did not. And in fact, his initial reaction when she showed him the Nobel-worthy data was a condescending rubbish, my dear, okay? But they'll never admit a mistake.
Never admit.
They've given Nobel Prizes for things that much later were found to be not true. And they will not take even those decisions away.
Yep. And they've given posthumous Nobel Awards. I point out 2 of the 3 men who won Nobel Prizes posthumously were Swedish. So go figure.
Are you still reaching the crowd here,
I'm not
Alex?
exactly sure, but it sounds like mine.
Can anybody hear Alex?
Okay.
It just sounded different to me somehow.
Yeah,
What?
which one?
Oh,
Oh.
Just something changed, so I thought it turned off, but whatever.
Is it still on? Oh, yeah. I don't
There you
think
go.
Hello, hello.
Yeah, there
we
you
go.
go. That's much better.
Well, in that case, I can take this thing off.
It's dust. Okay, well, we do want to have enough time for you to sign books.
Yeah.
Let's start with the question. I tell you, there aren't many people lining up. Do you people shy or
Come
something?
in from that other zip code over there.
By the way, I'm so
All right,
delighted.
Terry, I think you were first in line.
There are
So
all these friends of mine here. I'm going to take a picture because I see a whole bunch of friends of mine back there. Thank you all for coming.
Yes, thank you, guys.
Okay.
did you
Yes,
have to
over
pay 'em?
here.
Okay,
Okay.
first question is, Edwin Hubble discovered the expansion of the universe back in the 1920s, and he never got a Nobel Prize for it, so
Correct.
why not?
Yeah. So, I mean, I can comment, then Brian can comment. He actively campaigned for it, but I think he died in 1955, never having received it. But by the way, not to air too much dirty laundry, but Edwin Hubble was not the first to actually notice the expansion. And indeed, the Hubble law is now renamed the Hubble-Lemaitre law after a Belgian astronomer and priest who came up with the idea. And there were others, even Lundmark in Sweden, I believe it is, who had data showing similar things. And Hubble never referenced Vesto-Slipher for the redshifts of the galaxies that Hubble used in his plot in his paper. I mean, nowadays, if a professor to do this, that would be grounds for dismissal from the university if you didn't cite the source for half of your data. So Hubble was not exactly a saint, okay? And
So why didn't Lemaitre get it?
well,
No,
Lemaitre had died as well. And
There's another reason they didn't consider cosmology part of physics. They didn't consider astronomy, and Nobel was very specific. There was no Nobel Prize for math, there was no Nobel Prize for astronomy, and cosmology certainly was not considered properly part of physics. Yeah, thanks.
Thank you very much, Terry. Terry, by the way, is the chairman of the South Bay Hubble Admiration Society.
Okay. Very nice. And I should point out, Hubble overestimated, in the words of a former president, overestimated the Hubble constant by a factor of 7, in part because of, can anybody guess what was intervening? Thank you. Good job, A+. Yes.
So thank you. Alex, I have it on good authority that 2 + 2 does equal 5
2 + 2 does equal 5.
for large values of 2. It's true. I saw it written on a whiteboard.
For large
I'm
values of
concerned.
2, 2 + 2 equals. That's a little bit like that state that decided to make pi exactly equal to 3, right?
So anyway, non-results are not sexy. But do you guys know of any, can you think of any non-results that might have qualified for a Nobel Prize?
Non-results?
Well, I mean, I point out in the book, Penzias and Wilson weren't looking for the origin of the universe. You know, they were looking to find emission from the galaxy and to see how it behaved with position on the sky. And then this pesky signal got in the way, and then that was eventually interpreted by their competitors at Princeton University, who were unaware that they had acquired this data. Again, like Alex, serendipitously. So there aren't, necessarily too many null results. It's hard to get funding for, null results, but they're incredibly important. In fact, in our field, for many decades, there have been, upper limits, as we call it, and we're continuing to lower the upper limits until eventually we'll be forced to make a decision. Do we keep going and looking for the inflationary origin of the universe, or do we start considering alternative hypotheses, such as a cyclic universe, a bouncing universe, a different kind of universe altogether? And that's a question, in some sense, of taste. Yeah, thank you.
Thank you.
Can you address the size of the universe? I mean, when we think of it, the Big Bang, it happened out there somewhere. The Big Bang happened way out there. But the Big Bang kind of happened all around us.
Yeah.
And then there's a curtain that you can't see beyond because of the dust and probably other things. How do you get past that curtain? Is there a way? LIGO?
Can you see beyond the 3-degree background?
Yeah,
Is that what you're?
that's the goal of these cosmic microwave background polarization experiments. So if a firecracker goes off in the room next door from Berkeley, or some explosion from Berkeley happening up the road, supernova kind, we can't see it because we're inside this room, but we could hear it. So the lesson is you can detect things through other means of radiation and other means of clever detection. In our case, we want to go beyond this veil. It's not a veil of dust unless you look in the galaxy, but it's a veil of plasma. You're looking into a plasma, like all these electrons are basically reflecting light back to you or emitting light in a black body glow. So you can't see beyond that using light. But if inflation occurred, these waves of gravity would be so much faster than the puny waves of gravity detected by LIGO. The entire universe, not just 2 black holes, the entire mass of the universe springing forth in a microscopic trillionth of a trillionth of a trillionth of a second, at a minimum will create a huge amount of gravitational radiation. That's what we're trying to do with these twisting, curling patterns that we call B-mode polarization I describe in the book.
But just to add one more thing to that, if inflation really did occur, it made such an enormous total universe that most of it is even beyond the visibility that Brian was talking about, this indirect gravitational wave thing. In other words, there's an observable limit to what we can see, and most of what there really is beyond that. So in that case, we can't see much at all. And then, as Brian mentioned, there's also the implication in most inflation theories that it sprouts off and like the branches of a tree starts occurring elsewhere as well. And then you get truly into these multiverse ideas and stuff. So yeah, probably most of it we can't see.
If people ask you, could the universe be infinite?
Oh, yeah,
Our universe.
absolutely, it
Yeah.
could be infinite, yeah.
It could be, yeah, and it could be expanding into the infinite future, but, keep paying your taxes, because it'll take a while. Yeah.
So I come from the world of high tech, and in high tech, the success of a company is measured by the market. If your product is, so I would like to have your both thoughts why this physics community has settled on a bunch of people in Sweden who have never won Nobel Prize themselves, who are not particularly producers of Nobel Prize winners, because statistically speaking, not many Swedish people have won a Nobel Prize, and also they're not that committed to the scientific principle of correcting mistakes, because as you said, they never make mistakes. So what's the reason behind settling on Swedish people as opposed to Finnish or American or,
Right.
what is so special about them that everybody thinks that they have the right view of what good physics is?
I think they had what you would say in the Bay Area as a first mover advantage. That they started off and they had this great advantage. Nobel himself was a visionary. As Seth said, he wanted to do posthumous public relations for the amount of death that was attributed to him, incorrectly, probably unfairly. And in so doing, established this prize to really cement laws and ideas and technology. He was an inventor, 355 patents. He wanted to see inventions that benefited mankind. And then it morphed into very abstract things after World War II, searching for particles, fields, forces, a lot of, done up at Berkeley and here in Stanford, et cetera. And the question of whether or not it is reflective of that, but you're absolutely right. You look at the people that do it, it's like, you think that there's some godlike oracles that know exactly what should win at any moment in time. And I think that's unfortunate. And again, I claim in the book, it's sort of akin to this religion. It has a holiday. You go and you eat the special reindeer feast at the banquet. You bow down and you receive a literal gilded graven image of Alfred Nobel that we saw in the very beginning. It has all the hallmarks, in my humble opinion, of a religion. And so people don't like to give it up. It's so entrenched. There's so much lore, like with many religions. It's hard to disabuse people of certain things that may or may not be fairy tales.
Well, and then just to add to that, though they've made mistakes, and mostly of omission, like Jocelyn Bell, Rosalind Kennedy, and others, and they've made some mistakes in that they gave the prize for results that turned out to be wrong. In most cases, the people to whom they gave it were deserving. And, it's Einstein, it's Heisenberg, it's Planck, it's Bohr, it's all these very famous names in physics. I know those names much better than, say, in biology or whatever. And so, it builds a reputation based on the preceding awards. And so that's why it has such an amazing reputation. Now, maybe in a century, the Breakthrough Prize will have the same prestige. But Brian's right that right now, the Breakthrough Prize, though a larger cash prize, doesn't have the prestige of the Nobel, although it is growing, and I favor their way of doing things more than some of Nobel's rules.
If you do an engram, I think it's engram, you search the popularity of words over time. I compared the Olympics and the Nobel Prize and the Pulitzer Prizes. And nowadays, the Pulitzer Prize is nowhere near as prestigious for one reason or another as the Nobel. But back in 1930s, it was much more prestigious to win. So things come in and out of fashion. I don't think this will always be the case, but Alex is absolutely right. And I think it's because of that. But you also look at how few people have won it twice. Right, so you think the Einstein arguably could have won 7. Why didn't they give it to him? Because once you get it, the differential added benefit to the Nobel brand of their monopoly, which I talk about in the book, is incremental. It's very, very small. Versus giving it to someone else who can be woken up at 3 in the morning. This is the greatest day of my life, and and it's true. And so yeah, that's a very good point. Yep.
When I was a grad student, I remember being very surprised and shocked when we were told that one of the selection criteria for an assistant professor or a tenured professor might be, is this person likely to win a Nobel because they have a realistic shot at it? Could you just comment on, what the impact is, positive or negative, on academia?
You want to? I mean,
well, I'll start. I would say that though it's probably been that question occasionally in some departments. I've been at Berkeley as a faculty member for more than 30 years, and honestly, we do not ask that question of potential assistant professors that we're considering hiring. Maybe in physics departments they do, but that's, as I said earlier, that's such a high bar, right, that it's unreasonable to have that be an expectation for hiring an assistant professor. It's just completely unreasonable. So I would say no,
So
basically.
in my experience, it's been the opposite, though. I've had people say things like, you should get more money for your research because of all the people in XYZ department that I've been in over the years, you have this extremely high chance of winning a Nobel Prize if your experiment succeeds. Go in and demand a free grad student. I've had that happen. And I kind of laughed about it because I am, written this book and I have this relatively unpopular opinion that it does cast an aspersion or in some way a negative sense in the field that physics is done by authority, that there are authorities in physics. All you have to do is if you go to up the hill from where Alex teaches, you go up to LBNL, every single street has a name after a Nobel laureate. Down in San Diego, we have the intersection of two streets. One of my former students is here. It's Nobel and Laban. We have the second woman to ever win a Nobel Prize, Maria Gephardt-Mayer. Our physics department's named after her. If you go to any website of any national funding agency or any private funding, they'll talk about the contributions to Nobel Prizes. And even when Adam won, Adam's a friend of mine, they went back to his high school and said, his high school is celebrated, and it's certainly his undergraduate institution, MIT, celebrated it as if, MIT is a great place, but I don't think they had some special contribution compared to, to his Nobel Prize. So there's subtle hints, you're absolutely right, that are imposed upon young scientists. Yeah, thank you.
We have 3 more, not too many minutes left.
Yeah.
I asked the participants here for concision.
Yes.
I was kind of curious, in your book, do you talk about why Einstein never won the Nobel Prize for general relativity?
Oh, why did he not win a prize for? So for a long time, there was an anti-Semitic bias to the Nobel Prizes, and it became sort of a synonymous prize with experimental research. And cosmology was considered too theoretical, and theoretical physics was considered Jewish science by some of the founders of the Aryan Society of Physicists in Germany, who were some of the previous award winners in the Nobel Prize, previous Nobel Prizes, which few people know. Once you win a Nobel Prize, you're entitled to nominate future Nobel Prize winners for the rest of your life. So you get this rich gets richer Matthew effect where people tend to concentrate in clumps around certain prestigious researchers. And so he didn't win for that. He won for the photoelectric effect, which was related to this discovery made experimentally by Philip Lenard, who was Hitler's chief of Aryan science in Germany. And at that point, there was so much evidence by 1922 when he actually won it that relativity was correct. They probably figured it was almost like a greatest hits for Albert Einstein, but officially it was for the Brownian motion and for photoelectric effect, I believe.
So why would people in Sweden care about what, not people in Nazi Germany thought?
Because they were the previous winners of the Nobel Prize, so they were the advisors to the Swedish Academy, and it was, a very European-centric award. Americans didn't win it very often in the early days. Yeah.
So I thought I'd invoke a little bit of pop culture to this discussion. I'm a big fan of the Big Bang Theory TV series, and as you may know, the
Me too.
the last season focused on Dr. Sheldon Cooper winning a Nobel Prize in physics.
Right.
So I was curious, do you two, first off, do you watch it? Was it fairly realistic in terms of the Nobel Prize? And have either of you been interviewed by Nobel Prize selection committee members?
I served, as I talk about in the book, but don't tell anybody. I was on the committee. I was chosen to be an external nominator for the Nobel Prize in Physics in 2016. I was asked to keep that strictly confidential, though, so please don't tell anybody. I show the letter in my book, but yeah, so I'm not involved with the Big Bang.
And I'm not going to say one way or another.
Yes.
I missed part of the series of that last season, but something that I came into my mind as I was watching the few episodes that I did was that there were the two theorists, Amy Farrah Fowler and Sheldon Cooper, but there were the two experimentalists too, and so I immediately said, there's 4, they're going to have to wait for one of them to die. But apparently it got resolved some other way. I'm not exactly sure how.
Okay.
It would seem to me that the Nobel Prize could possibly result in a decision by individuals that were chasing it, to not share their data with other people that are outside their team, which to me would then make it so that it could actually slow down discoveries because nobody's really trying to work together, et cetera. Is there any truth to that? Or
Yeah, there's been a study, I won't ask Alex to comment on this, but there's been a study by a sociologist of science, Harriet Zuckerman, I think is her name. I talk about it in my book. The effect of a Nobel Prize in the collaboration that was eligible to win a Nobel Prize, where only one or at most 3 people won it. And she found this huge decline in the collaboration. The collaborations tend to dissolve very quickly after one person wins a Nobel Prize. In some cases, they stay together. But the Nobel Prize is won mainly by experimentalists nowadays, or observers in our case, present case here tonight. And by theorists, it's hard to say, which person, if you remove the person from a 1,000-person team, which person is so key that experiment wouldn't have won a Nobel Prize. With a theorist, if this person, Peter Higgs, and there were 7 people I talk about in the book could have plausibly won the Nobel Prize for the Higgs prediction. But the effect has been negative in a lot of ways. And imagine if you had this Olympic swimming relay race, which has 4 people on it, the women's 300-meter, 3x4x300, whatever it is, and only 3 of them get the gold medal. What do you think that would do to the 4th person? Would she want to swim with them ever again? No. It's just completely arbitrary and unfair.
Yeah, although, if you are doing an experiment that a lot of people think might be Nobel worthy in the end, I would say that the team spirit is still there. You want the prize to be given for that discovery. You want your discovery to have been correct, and you want to have learned something new about nature or the universe that no one in humanity has ever known. And so, in our case, even when we found the result, and it was clearly bizarre, and we weren't sure whether to believe it, but we thought there was a good chance we're right, the collaboration stayed together and remained friendly, and I would say that there are not clearly any hard feelings that only 3 of the 50 people got it. It's just the rules, even though those are not even technically the rules, and it's nowhere in Nobel's will that it goes to a maximum of 3.
Right.
But outside of the team, did you care to share your information with Germans?
Well, you don't share it right away for the reason that competitors could go and publish the result first, and it might not even be that they just say, "Ooh, that's a cool result, let's go and steal it." It could be, as in Brian's case, that there are more than one team that are basically going after the same thing at the same time. And if you reveal too many of your cards, right? If you're a good poker player, you don't reveal your cards. That could compel the competitors to work faster and publish their results sooner. So you don't want to reveal your cards too much.
If there wasn't a Nobel Prize, then you could...
No, it would still be the case because there's funding and other prizes and prestige and so on. Again, so few discoveries get recognized with the Nobel Prize that in most cases that's an unreasonable ideal to which to aspire.
All right, I'm going to call the questions now. In 2 minutes, Brian is going to go back into the lobby
And
with
Alex.
his
Marker, Sharpie.
with his
Alex.
Sharpie,
Alex, too.
and
Sharpie?
wreak havoc and
Sharpie.
destruction on either his book or whatever maps you may have brought along. And but since we have 2 minutes, 1 minute each, do you think we're going to learn whether there is such a thing as a multiverse, whether that's truth or merely an interesting idea in the lifetime of the people in this audience? You get 1 minute.
Okay, so there's a famous bet made by Andre Linde up the road here in Stanford, Martin Rees, and Steven Weinberg, whether their confidence was in the multiverse, to the level of whether or not they'd bet their life, their dog's life, or their fish. And Steven Weinberg said, "I'm not that confident, but I'll bet their lives and their dogs that the multiverse is real." So I talk about this. I've gotten a lot of controversial comments on, whether or not the multiverse is kind of in the realm of faith-based, evidence, whether or not you take things based on faith or not. There's a lot of circumstantial evidence. I think it's very strong that the inflationary model might be correct, but there might be many ways in which the multiverse doesn't occur. So the multiverse is that there's an infinite number potentially of meetings just like this happening all throughout this vast region of all connected universes or possibly disconnected universes. Seems to be a consequence of inflation. I think that this would be one of the most profound discoveries of all time. And I do think, when my friends say it, say it's just a matter of time before we detect it, I say be careful when a cosmologist tells you it's just a matter of time. Could be another billion years or so.
Yeah, okay. Alex, the question to you is the obvious one,
a quick-
dark energy.
Oh, dark energy, okay, right.
Are we going to figure out what it is?
Yeah, are we going to figure out what it is? We're setting better and better observational constraints on it, but I think it'll be extremely difficult to prove that it's a vacuum energy versus, that is a property of the vacuum itself, versus a form of energy like light, but different from light, that permeates space. There's a subtle difference between being a property of space itself versus a new type of energy that permeates. And the problem is that to show that it's a property of space, you have to measure its value now and all of its time derivatives precisely. And that's never going to be done in the near future. If a measurement were to be shown to be inconsistent with the vacuum energy, then that would be definitive. But the answer right now is so close to being consistent with a vacuum energy that I think it's going to be extremely difficult to get an answer that's definitively different from the expectation of a vacuum energy.
Does it satisfy everybody?
No. But that doesn't mean we'll stop trying to figure out what it is, okay? This is just my opinion.
All right.
It'll be hard.
Thanks to our guests here. Thanks to you for coming. For those of you who don't do it routinely, check out the SETI Institute's website, SETI.org, and go buy a book from Brian here. He may sign it.
Thank you.
Thanks very much.
Thank you, guys.
Okay, thank you.
Thank you.
Oh, I didn't do anything. Oh,
Can we get a mug?
yeah, I'm sorry. This is unforgivable.
Mugs.
But,
Mug shot.
we had a discussion whether you guys wanted the $5,000 honorarium or one of these mugs.
We'll have the honorarium. That's okay. There you go.
I have you down for talking to PAS on Saturday, October 12th.
Yeah. That is Columbus Day, of course.
Sure, you're welcome.
But maybe nobody cares. I'm pretty sure.
On Monday.
Send me an email this week. I'm pretty sure it's on my calendar. I mean, I put it on there, so I just want to check.
Okay, and we're still nailing down the exact room you'd speak in, but that's,
Yeah, that's neither here nor there.
we'll
Great.
know soon what room.